Good evening, all of you. Welcome, you guys. Welcome, you all. Welcome, you guys. First of all, so do check this thing. Is the audio video is clear or not? Yes, am I audible? First of all, you tell me now here. Is the audio video is clear, everybody? First of all, comment. So, am I audible to all of you? Is the audio video is clear to everybody? So, let's start our discussions. So, chalo, let's continue our discussions. Fine. I hope I am audible to everybody, right? So let's continue our discussions. So we are discussing the electromagnetic field theory. So let's have a brief discussion. We have a great announcement from this Unacademy team. So you can see this thing. And so Unacademy is conducting this all India mock test. With this mock test, you will get to know so what is your preparation level and where you have started and what are your weak areas and where your strong areas you'll get to know, and at the same time you will get to know your all India ranks you can able to get to know, and you can enroll for this test series by using the code B V Reddy, and you can have a great experience. You will feel the real GATE experience आपको मिलने वाला. Fine, all of you do share this class link to everybody and let the maximum students will get benefited, and all of you immediately enroll for this all India mock test by using a code B V Reddy, and you can have a great experience. And so as we are very nearby to the GATE exam, so we do providing this it is the Unacademy subscription with a less price, and that too with is a no cost EMI. Without paying any additional charges you can avail it, and the notes are available on the website. You can access the digital notes, and these are new batches we are starting. You can see now Aditya sir is starting the new batches, and from the November 24th onward started for the GATE 2024, and you can join this batches by using a code B V Reddy. You will get the maximum discount and personalized guidance from me. Right, these are the electrical batches. These are the new batches we are running for the 2023, the short-term courses, and you can have a look at now here. You can plan this Unacademy Lite test series for 4 month के लिए just 499. Unacademy Lite test series, fine. And these are the benefits of the Unacademy. The plus features are the top educators will take the classes, digital notes, test series, and iconic students will get additional benefits of customized doubt solving, printed notes, one-to-one mentorship, strategy and study program, and interactive open house sessions. Now, so in the previous class we have discussed about the coordinate system हमने complete किया. So here today we are going to discuss about the vector calculus. And let us briefly revise the things what we have seen yesterday's class in the coordinate system. The most important thing points will revise. All of you देखो इधर notes, make a note here. In Cartesian system, what are the elements we have seen? X, Y, Z. Can you tell me change in length along X direction? Change in length along X direction is dx. Along the Y direction, change in length is what? dy. Along the Z direction, change in length is dz. So by knowing this one change in length along X, Y, Z, so we can able to write the dx, dl, dl, ds, dv easily. Everybody. So by knowing this dx change in length in the corresponding direction, we can easily write the dl, ds, dv. Fine, all of you. Now similarly, now let's tell me now here what is the change in length in the row direction, which is called as a d row. Along the phi direction, change in length is rho d phi. Smadanina pizza. And change in length along the z direction, which is given as what we can say dz. Now similarly, change in length along the rho direction, r direction, which is a dr, along the theta, that is r into d theta, along phi is what you tell me, that is r sin theta into d phi. Isn't it, everybody tell me? Along r theta phi. Done. So by knowing this thing, we can easily write now here. For example, now tell me now here, if I ask the ds, I asked for ds in case of a, so here tell me now in case of a theta phi plane, tell me here. If I ask the ds in case of theta phi plane, tell me what I can say. Theta phi plane in the ds, which is given as what? Theta phi plane, which is given as what I can say. Change in length along theta, change in length along phi, we have to multiply simply. What I will get, you tell me. This is r square sin theta, so that is d theta and d phi, and direction is what direction I can say here? Perpendicular to theta phi, which is ar cap. Is it easy or not? अगर मैंने, so here dv, if I ask differential volume in the cylindrical system, tell me differential volume in the cylindrical system. So the cylindrical volume case, we require all the three elements are required now, and volume is a scalar quantity. So simply multiply all the things, what we can say, rho, d phi and dz. Okay, all of you बोलिए. Excuse me. Done. Now you tell me now here. Now, so among these all the coordinate systems, and which coordinates you like, you tell me. आपका कौन सा coordinate system अच्छा लगेगा? Which coordinate system you like, to tell me. Of course, everybody will say the Cartesian system. हाँ ना बोलिए. Everybody will say the Cartesian system. Fine. So now you tell me now. My question is, Cartesian system is a very friendly coordinate systems. Everyone will like this Cartesian system, and even we can easily visualize. So xy plane, yz plane, zx plane, we can easily imagine. In our room itself, we can imagine xy plane, yz plane, zx plane, we can visualize. But so that means we have easy system, coordinate system is there. Now my question is, what is the necessity to learn these other coordinate systems? This question is, what is the necessity to learn the other coordinate system? We are very much comfortable with the Cartesian system. Then why the comfortable coordinate system छोड़ के और दूसरा coordinate system को क्यों जाना पड़ेगा? What is the necessity to go to the other coordinate system compared to this thing, Cartesian system? That means that as we have seen, cylindrical system and spherical system, the visualization complex lagega, will feel not that much. It is not easy to visualize the cylindrical system and spherical system, right? Now that means what we are doing now here, that means we are moving from the easy to complex. Do you say that? So here आपको ये doubt आया होगा, I think so शायद. Yes, did you get this type of doubt? Why we are moving from the Cartesian system to other coordinate system? What is the necessity to move the Cartesian system to other coordinate systems? Easy coordinate system छोड़ के complex को क्यों जाना पड़ेगा? That means, do we think this we are moving from the easy to tough situations? Do you think that we are moving from easy to complex, or huh? Now see this thing here. Just have a look at here. Simple example I am telling. So I think so you might studied the integrations. Now here let us consider we have something here, we have x integration, y integration, double integral. Now let us consider we have some function is there, integration of something here, x square plus y square into dx and dy is there. I want to find the integration, x limits, y limits, something they given. Now you tell me now here, if you want to do this integration of this function, आप क्या करना पड़ेगा? You tell me what you have to do here. एक बार स्मरण करिए, आपको मैथ्स का नॉलेज अच्छा होगा, I think so. So tell me what we need to do here. While we are integrating with respect to x and we'll treat the y as a constant and we'll do integration and substitute the y limits, and thereafter we should do x integration. हाँ ना बोलिए. Is this type of integration, is it is easy or tough? You tell me. Doing this thing here, do you feel it is easy? Is it is a easy or tough situation? Doing this integration, this is it is not easy. Now tell me all of you. आना बोलिए, it is not at all easy thing. Now अभी देखो इधर, मैंने क्या किया? I have taken this as x is equal to I have taken the something I am going to do here, that is x is equal to I am taken as a r cos theta, y is equal to I am taken it as a r sin theta. Now then x square plus y square, which will become this as a r square. Now I can change this integration x y integration to r theta now here. Now this will becomes what you tell me now here, that is 1 by r into we have dx dy. Tell me now what is the integration? We have dx dy is there. In place of dx into dy, what we used to write? You tell me now here. What we used to write now here? We are converting into what now? Spherical cylindrical system now here, which we write it as r dr d theta. आपको स्मरण है कि नहीं? So it will becomes r dr d theta will write, isn't it? Now अभी देखो इधर this thing, what happens? You tell me now here, r integration, theta integration. So this is dr d theta. Is doing this value is easy or difficult? You tell me. अभी बोलो इधर क्या होगा? This simplification is easy or difficult? This simplification, is it easy? Doing this thing here, just substitute the limits only ना, इसमें कोई खास बात तो नहीं ना. Tell me, do you feel it is difficult now? Do you feel this is difficult or not? Now it is completely simple, easy or not? बोलिए all of you. अभी बोलिए now here what you want to say now. अभी आपको क्या पता चला इधर? Now you tell me now here. By doing this thing, इसको क्या पता चला now here? So here we have converted this as a Cartesian system to what system now here? This the polar form is nothing but what now? Cylindrical system. So cylindrical system को polar form convert करने के बाद, so this integration बहुत easy होगा कि नहीं? Yes. So this is, it will become easy or not? So it is very easy. A Jacobian वो सारा here इसमें, so here maths में used to study the Jacobian. अगर इधर what we study now here, and we simply remember this thing as like this now here, and you tell me now one point here, why this r will come extra here? But a change in length along r is a dr, along theta change in length is what? R d theta na. That's why extra r will come here. Fine. Now you tell me now here what we are doing now. Whether we are moving from the easy to complex or complex to easy. By knowing so with the help of the other coordinate systems, now the problem solving will become easy or difficult? Problem solving will becoming easy. Now understood now why we need to go for other coordinate systems? Now you understood now why we need to go for other coordinate systems? Fine. Chalo. Now let's have a brief look at here. This is the short notes have prepared for the electrical EMF के लिए. Just have a look at now here. Just have a look at now here. ये सारा जो हमने डिस्कस किया, so यहाँ इसमें आई. So सारा concepts. एक बार देख लो इधर सभी ने. ये ब्रीफ शॉर्ट नोट्स अभी तक जो डिस्कस किया, ये कुछ आने वाला भी, ये कॉन्सेप्ट भी आने वाला, यहाँ से आने वाला, सो वो कॉन्सेप्ट बचा है. फाइन. This short notes also I will provide you to all students, and to get this short notes and all, you fellows, you need to follow, you follow me in the Telegram group. So that is, you can search in the Telegram group, that is a BV Reddy. You can search in the Telegram now here, that is BV Reddy. BV Reddy GATE. There you can find my profile. You can search my personally. This is BV Reddy Telegram channel. This one. This is completely Telegram group. Is it not visible properly? Right. Right. Fine. Not visible. I don't know then here. So are you facing any problem? Tell me first of all. Are you facing any problem? So बाकी को ये problem होगा क्या? Is it visible to you, remaining fellows? If you are anybody facing this problem, tell me. Visible now? Fine. So here I'll discuss this thing. Notes, yes, you do message me there, yeah. So then there you can get, you can go and search in the documents. I send so many documents are available now. You can search in the documents. There you can find. Y will take the theta is up to 0 to pi. Fine. This thing. So here, shall I discuss this topic? I plan to start the vector calculus here. Calculus I plan to discuss. So here shall I discuss this your doubt, Himanshu? So why the theta is from 0 to pi? So here बाकी को भी ये doubt आए क्या? If the remaining fellows also will have this doubt, why the theta is from 0 to pi, why not till 2 pi? Right. So here shall I discuss this doubt or will move to the next topic? Tell me. Shall we discuss or not? Hana bolo yaar. So here shall I in spherical system na here. Fine. Let's have a discussion then here. Then look at now all of you. Now look at now here. As we have seen in the spherical system, the elements are r comma theta comma phi. Boliye. And we don't have any problem for the r. Tell me. We don't have any problem for the r. Let us simply consider r is equal to something 10. R is equal to some 10. Next. So you tell me now here, and so how this axis you tell me now here, all of you ध्यान से देखो इधर. This is my x axis and this is my y axis and this is my z axis. Look at now, let us consider I am changing the theta is from 0 to pi. Let's see what's going to happen. If I first we apply the theta condition. Now you tell me now here. So what theta is the angle with what axis? Tell me first of all. Theta is the angle with the z axis. When theta is equal to 0, we have a point lies on z axis. Yes or no? With a radius of this distance is how much? You tell me 10. Yes, with a distance of how much you tell me now here? This is 10. Now this is theta. Now I am changing the theta value, changing from the 0 to pi. Agar if the theta is equal to 30, so we have point here. Yes, 60 here, 90 the point is here, 180 the point is here. All of you tell me. Then, so if I join all these points now here, I have taken, you see this thing here. Here theta is a continuous or discrete, tell me first of all. Here theta is a continuous or discrete. Theta is a continuous. That means we can take the theta values some 0 to pi, we can take so many values are possible or not. So many values we can take. So as a result, so we can get one semicircle will form now, tell me all of you. With this will form a semicircle. Boliye, this thing clear now? First of all. Thereafter, now you see the phi. What is the phi, you tell me? Phi is the angle with the x-axis. Now you tell me now here, if we apply the phi condition, phi value that is from the 0 to 2 pi. Phi is equal to 0 to 2 pi. Now you tell me now here, if I have taken this point, some random point we have taken, if I apply the phi condition, phi if I change for this random point, if I apply the phi value from 0 to 2 pi, what's going to happen? So I can form one circle, we can form where we have started. So will be returned back the same point or not? 0 to 2 pi? All of you boliye. I am at this point, if I by maintaining the r value constant, if I move the theta is from 0 to 2 pi, then I will do make a one circle, I will make it like, now tell me all of you with the same radius, what are the radius we have? Now अभी देखो इधर, I have taken this point, I have taken, ध्यान से देखो, if I apply the phi condition, what happens now? I will form one circle like this, and if I have taken the this point randomly, I have taken some discrete point, thereafter we can apply the continuous. I have taken this point now here, if I apply phi condition, I will get a circle like this. I have taken this point, if I apply the phi condition, I will get a circle like this. This point we have taken, we can form a circle like this, like this. Keep on, we can form the circles like this. All of you tell me. अगर आपने ध्यान से देखा तो here I have taken randomly, we have taken this point, some points only we have chosen, isn't it? I can take the continuously, we can take so many points we can take or not. By taking the continuously points, now this point will go form a circle like this. If I take this point, we can form so many circle we can form now. Just imagine now here what a shape I can form. Because of this we can form this this part will complete or not. एक बार ध्यान से देखो इधर, we can form a sphere, we can form or not. This is exactly a sphere. Ana boliye. So here this is exactly, if we can develop this MATLAB program, you can able to clearly visualize this thing, isn't it? Now you tell me now what is the phi value I have taken here, 0 to 2 pi, and theta value what I have taken, you tell me. Theta value I have taken only 0 to pi only I have taken. So you tell me now here, when I have taken the theta is from 0 to pi, I formed this semicircle I have formed. This half circle we have formed. अगर आपने theta value 0 to pi ले लिया तो, if you have taken, then instead this one, you will get this circle also will come. This part also will come. Yes or no? Tell me, full circle आपको मिलेगा. But लेकिन ये left वाला semi circle, half circle, so this we are forming with the phi condition only available na. We are forming this thing with the phi condition only, isn't it? Then that means with the 0 to pi only I can able to form a one full sphere I need to form. Then why we need to go for till 2 pi, tell me? So why we need to go for till 2 pi? So my phi, so just 0 to pi only I are forming a sphere, then no need to necessary to go to the till 0 to 2 pi na. आना बोलिए, is it clear now here? इसीलिए we used to take the theta is from always 0 to pi. 0 to pi is my sufficient. We know no need to go for till 2 pi. चलिए, clear now this thing? कोई शक वाली बात नहीं है इसमें? कोई शक है क्या इसमें? डन। चलो हम आगे बढ़ेगा, और कोई डिस्कशन चाहिए बोलिए इसमें। शैल वी मूव नेक्स्ट टू टॉपिक, टेल मी। बोलो यार, अगर कोई डिस्कशन, इफ यू आर नॉट सैटिस्फाइड लेट मी नो हियर, सो आई विल एक्सप्लेन सम अदर थिंग्स। ओके, so tell me the next topic here, vector calculus. Vector calculus. And the vector calculus, here we are going to discuss about three topics we are going to discuss. One is vector integration, vector differentiation and vector theorems. Three topics are important things. All of you ध्यान से देखो इधर. Vector integrations. Vector integrations. If we have A is my vector quantity we have taken. A is a vector quantity. So this is integral of, this is integration of A dot dl, and so which is called as a line integral. This is called as what? Line integral. Integration of A dot dl, which is called as a line integral. Line integration means we are finding the integration of some random vector. Let us consider this is from A to B. Along this is the path, where L is the path of integration, L, or we can use a contour C. So if this my path of integration is a closed path, means I have moved the integration from A to B, I have moved. Again I come back to the initial point now here. Then this path, which is called as a closed path. This is called as what? Closed path. How we can integrate the closed path integration? Like this. That is a closed line integral of A dot dl, where this bubble over the integral will indicate the path is a closed path integral. So which is called as a closed line integral. Okay, this is called as what, you tell me? Closed line or closed path integral. And integral of surface, yes, will indicates surface integration of A dot ds. This is called as a surface integral. This is called as a surface integral. If my surface is a closed surface, and we can indicate it as like this. If the surface is a closed surface, then the integral which is given as like this, closed surface integral like this. This is called as a closed surface integral. This is called as a closed surface integral. Right, here if you see carefully, this is line integral is a single integral, and where this S indicate, that is a surface integral. By default surface integral is a double integral. By default surface integral is a double integral. Right? Next, and the volume integration, which we can indicate it as volume integration of magnitude of this vector into dv. This is called as a volume integrations. This is called as a volume integral. Right. Now, so here the things are, we need to concentrate some important things here. You can see the terms here: line, closed line, surface and closed surface. These terms में हमको क्लैरिटी आइडिया होना पड़ेगा. देखो इधर line, what is meant by line? Line, closed line. Surface, closed surface means what now here? Closed line is there means there might be open line also. What is meant by open line? What is meant by closed line? How we can distinguish between these two? And what is meant by open surface and what is meant by closed surface? Right. So here if you see carefully, actually yes, your doubt is correct. Line, by default line means it is an open line. Remember, we are habituated to use the word of line. By default actual name it is an open line, and by default surface is an open surface. Right. Open line and open surface. We are simply habituated to use the word of line, surface, like that. Okay. Now let us understand what is meant by line and what is meant by closed line. So just look at now, let us consider all these terms are defined with respect to the path of integration. Let us call this point is A, this point is B. I want to find the integration of one vector from A to B. So here this is called as a line. This is called as what to tell me now? Line. And let us consider I want to find the integration of a one vector along the path. Let us say this is A to B. And so I have moved from the B to C. And I have moved from the C to D. Again I have come back to the A. Right. So this line, this is called as a closed line. This is called as what to tell me? Closed line or closed path. This is called as a closed line or closed path. अगर आप ध्यान से देखा तो here, so this thing in the moment of coming back to the point A, have covered this much of area, have covered, you see, I have covered this much of area, I have covered, right? This much of area I have covered. So this one, if I cut this piece in this path, so what I will get now here, we can form some surface is formed or not, isn't it? This surface which we used to call it as a open surface. What we will call this as a, this is called as a open surface. Basically this is what you tell me now here, closed line. Basically this is a closed line, and this closed line which is also equal to what you tell me, open surface. The closed line is equal to what I can say, it is a open surface. Is it clear? You tell me. It's a open surface. Now let us consider this is my some random open surface we have considered. This is my open surface. Now I am closing the surface from all the sides. From all the sides. Here we have, this is the open surface, right? Initially I am closing the top surface. देखो इधर, top surface, and closing the right surface, right part, and bottom part, left part. You see this thing here. Now what I should call this is, you tell me now here. So this which we should call this as a closed surface. Hana boliye. This is called as a closed surface. Now अगर आपने ध्यान से देखा तो here this is a closed one, so it is having the volume. You see carefully, in the formation of, in the process of forming this as a closed surface, here what I did now, here I have formed the volume, you tell me, isn't it? So it is having the volume now, right? So from this what I can say now, here the closed surface will forming a volume, the closed surface will forming a volume. Is it fine, all of you? Right. So here now in general, is it point clear to everybody? In general, what I can say here, in general we can summarize the things as, yes, line is a one dimensional figure. Line is a one dimensional figure, isn't it? Now closed line and which is a 2D figure. Hana boliye, closed line is a 2D figure, and the closed line is nothing but what? Open surface. Closed line is nothing but what I can say? Open surface. Next, closed line, closed surface, closed surface is what I can say now here, which is a 3D figure. Closed surface is a 3D figure, and this closed surface is forming what to tell me now here? Volume. Can I conclude this thing? Tell me, all of you. सबीना जोत से बोल एक बार, जोत से बोल. Line is a 1D figure, closed line is a 2D figure, and closed surface is a 3D figure. Right. Any one dimensional figure is called as a line. Any 2D figure is called as a surface. Any 3D figure is called as a volume. Done? Done, all of you? Right. So कोई कष्ट तो नहीं ना, बोलिए सभी को. So here, so सभी आपको अच्छे से समझ में आया ना this thing here, everybody? चलो हम आगे बढ़ेगा, बोलिए. And here what else we can आगे बढ़ेगा. So here briefly we can able to conclude the things. Right. चलो नेक्स्ट टॉपिक वी आर गोइंग टू डू. या बोलिए, देखो डाउट्स का रिक्वेस्ट करने की जरूरत भी नहीं है, डायरेक्टली डाउट पूछो. सो ओके, सो डायरेक्टली वी कैन डिस्कस. सो हियर एंड जनरली द यूट्यूब में कुछ सो है सर, क्या आप ईएमएफ एंड वोल्टेज का बीच डिफरेंट? यस, ईएमएफ एंड वोल्टेज. सो टेल मी नाउ हियर. Yeah, so this thing when you are discussing about, okay fine, so here and Ahmed, so then so I will discuss this thing here in more clearly when you're discussing the concept of the Faraday's law. There you will get the actual feeling aayega. So there I am going to discuss about the different type of EMF, that is a motional EMF and a rotational EMF, statically induced EMF, dynamically induced EMF we have now. So there I will discuss with real examples I can able to explain. So now we are not in the topic, so here do attend the class regularly. When I am discussing the Faraday's law, that time I will discuss this topic. Okay, if I forget, and remind me this thing. Right. Chalo, let's talk about next topic, that is vector differentiations. So first topic I am going to discuss about in this vector differentiation, gradient operations. ऑल ऑफ यू ध्यान से देखो इधर, कॉपी हियर, यस राइट. सो हियर ऑल ऑफ यू ध्यान से देखो इधर, gradient is defined for the scalar function. First of all, remember, gradient is defined for what quantities? Only for the scalar quantity is defined. Gradient of a scalar is a vector quantity. Gradient of a scalar function is what? Which is a vector quantity. Vector quantity, resultant of a gradient is a vector quantity. That gives what it will use here? It will use magnitude and the direction of the maximum space rate of increase in V. Maximum space rate of increase in V means, here we have taken V is some scalar quantity. I want to find the gradient. So here gradient of a function, which we can indicate this thing as a gradient of V, and which we can write as simply as a del V. Okay, del V, right. So here del V. Now, so what is this gradient? Physical meaning try to understand आप सभी ने ध्यान से देखो इधर. Del V, which is equal to what? You tell me. Del V is a, it is the variation of the physical phenomena with respect to space parameters. Now can you tell me what are space parameters? What are spatial variables? What are spatial variable? Tell me now here. Cartesian system, if you consider x, y, z are the space parameters. That means what I need to do here? I have to find the variation of the scalar V with respect to space parameters. With respect to space parameters. So what we can say now here? The variation of this V with respect to space, what I can say now here? That is del V by del x. So if you see carefully, so time is not a space parameter. Yeah, space parameters means x, y, z are space parameters. Time is different. Nah, time is not a space parameter. Now you see this thing. What is this thing here? Here del V by del x will give what? That is a magnitude of variation of the V with respect to x. Magnitude of variation with respect to x. Now what is the direction of this variation? Tell me. What is the direction of this variation? So this is the magnitude. This is what you tell me. This is the magnitude, and this is varying along what direction? X direction. So that's why we can use a corresponding its unit vector as ax cap. बोलिए. Similarly, rate of change of V with respect to y along what I can say now? Ay cap. The rate of change of V with respect to z into az. Tell me all of you. This is called as a gradient operation. The gradient of a scalar is a vector quantity. It gives what? The variation of the V with respect to space parameters. What are space parameters? Are x, y, z are the space parameters. It will give us a variation with respect to x, y, z. Is it fine? All of you tell me. Now, vector and scalar field का real example क्या होगा? I know vector and scalar, but vector field and scalar field. सुनिए now here. So if I given this something, a vector, if I given here, let us consider here. Yes, if I given 2i plus 3j plus 4k we have, then we can call this is called as a vector. If I have given this as a is equal to, this is 2xy square into I plus 3yz, randomly I am taking, into j cap plus 4x into k cap. If we have like this, then this is called as a vector function. Then we can call this as called as a vector function. Is it fine now? Tell me. This is called as a vector functions. Fine. This is the difference between a vector and vector function. Means it should depends upon the parameters. It may be whatever it may the parameters x, y, z में depend होना पड़ेगा. किसी तरफ से it may depend on the x, y, z. Done? Fine. Chalo. Now let's talk about the divergence. Let's talk about the divergence. And before this, we have a gradient in the cylindrical system. We'll see. So we have seen Cartesian system parameters are x, y, z. Now let us see the gradient in the cylindrical system, del V. In cylindrical system, what are the parameters we have? That is rho comma phi comma z, right? So those things. Tell me now del V, which is given as dou V by dou rho into what you tell me now, A rho. The change along with respect to rho. Fine. Next, along phi, what we can say now, this is 1 by rho into dou V by dou phi into what we can say, this is A phi plus dou V by dou z into Az. Is it fine, all of you? So this is the gradient operation in which system, you tell me? Cylindrical system. This is in what system? Cylindrical system. And coming to spherical system. Spherical system, the parameters what we have? R comma theta comma phi. R comma theta comma phi. Tell me now gradient in the spherical system. We can say del V, which is given as change with respect to R, what we can say now here? Del V by del R into AR cap plus 1 by R into dou V by dou theta into A theta cap plus 1 by R sin theta into dou V by dou phi into A phi cap. Fine, all of you, tell me this thing. These are the gradient in what system? Spherical system. Done, everybody? And so here, and all of you try to be interactive manner. So here, अगर कोई concept होने के बाद, if you have given me, so you are following, you can understand. So then I feel very happy you are following. So then I will go to the next topic. So अगर if you don't give the response, then I am waiting for your topic. So your response. अगर आपको ये topic समझ में आया कि नहीं, or if you are given a late response, then if I move to the next topic, then here after starting the next topic again come back to the previous topic, so it is not good, isn't it? So that's what I am expecting here. So here कुछ topic समझ में ने के बाद, if you have given some response following yes like this, then I will fastly will move. Otherwise I need to wait for your response. So ultimately the thing is, so I am discussing for you fellows. If you understand, then obviously the teacher, as a teacher, I will be happy. Fine. So that's what. So all of you try to be interactive. So if you understand, if you are following, fine. So very good. So give me response. If you are not able to understand any topic, and just ask. You know, so you directly ask your question. So I have doubt in this topic. I want this topic something. Directly I will discuss. Fine, chale, next topic, all of you tell me. Right. Next talk about the divergence of a vector function. Divergence. इधर ध्यान से देखो इधर. Divergence which is defined for the vector quantity, remember. So here divergence which is defined for what you tell me, vector function. Vector function. What a divergence meaning is now here, it is gives a measure of net rate of flow. Measure of net rate of flow. Diverging, the name itself indicates it is what now is spreading, expanding, leaving from a point. अगर let us say this is the point we have taken, अगर आपने ध्यान से देखा तो here from this point the something is leaving, it may be anything, whatever it may be. So this is what we no need to focus now here, something is leaving. So then we can call this field is what nature, we can say diverging nature. If the field is leaving now, we can call this as what you tell me, diverging nature. So if I simply just a practical example, I have taken one balloon. If I put a hole to balloon, then what happens now here? The air will be diverge. Yes or no? So that leaving nature is called as a diverging nature. If anything is leaving, we can call that nature is a diverging nature. Right? So these are physical meaning of a divergence. Now if we have taken now in general this divergence of a quantity, it may be positive and it may be negative and it may be zero also. Divergence of a quantity, it may be positive, may be negative, may be zero also. Divergence is positive in case of a sources. In case of a source, divergence is positive. And divergence is negative in case of a sink. And the zero means that is a neither source nor sink. Neither source nor sink. Right. Now. So, and let us consider some scenarios now here. I have taken this point here. Yes, from this point here, if we have field lines are like this. Field lines are like this. Now you tell me what I can say now in this case. So here, field the lines are like this. Can you tell me divergence at this point here? Divergence I am calculating at this point, at the center point. What I can say now here, positive, negative or zero. Positive, negative, zero. So which is a positive? All of you boliye. So this point is the source, I can say na. This point is the source. Right. Next, let us consider some other scenario. I have taken some point here. Let us say at this point we have some field is like this. We have the field lines are like this. Consider here. At this location, can you tell me divergence here? At this location, what a divergence I can say, which is a negative. So what I should call now this point, we can call this as a sink now, tell me. This point is called as a sink. It is taking some field. Now some other scenario here, let us say we have the field lines are like this. Consider. We have the field lines are like this. Yes, yeah, in the first class में हमने discuss किया ना. First class में हमने discuss किया this thing about the physical meaning of divergence. So here, if anybody not attended the first class, do watch the first class. Right. Now, अगर आपने ध्यान से देखा तो here you tell me now here. Have taken this point. All of you ध्यान से देखो. All of you ध्यान से देखो इधर. Listen carefully. So here, if we have considered, sorry. Now, if we have seen this thing here, if I close this right side part, how the point will appear, you tell me? How the point P will appear, you tell me. If I close the right side part, if I close it now here, how the point P will appear? It is taking the fields. This point will appear like a sink. Then this point will appear like a, what you tell me, sink. अगर मैंने ये लेफ्ट साइड को क्लोज किया, if I close the left side, if I close this thing, how the point P will appear? How the point P will appear? It will appear like a source, isn't it? That means if you see carefully, whatever the field lines are coming from this direction, the same field lines are moving in this direction, or tell me, same field lines are moving, yes or no? Is the point is giving anything, you tell me? Is the point is giving anything? No, the contribution of that point P is nothing. So here whatever it is coming and same thing is going. Whatever it is coming, it is same thing is going. Yes or no? So I can say the point P is a neither source nor sink. What I should call the point P is, now tell me, neither source nor sink. So here it is not giving, not taking. Okay. Now, so if you have considered this as the best example, source. Now you tell me, if you consider your parents are the source for you, tell me. Parents are the source. Now you tell me, what is the divergence at your father, at your parents? What is the divergence at your parents? It is a positive. Your parents are the source for you, right? Now here at your case, you are the sink. You are absorbing, you are consuming, you are dissipating. So that means, so at your case, divergence is negative. Is it fine? At your parents, it is a positive, and at your case, it is a negative. Is it fine, all of you? Now coming to the small example here, let us consider your father sent a money order to you. Let us consider. So here your father sent a money order to you. Then you just imagine, try to visualize. And what the postman will do, tell me? The postman will take the money from your parents, and whatever the money he has taken, that money he will pass to you. Whatever the money he has taken, the complete money he will pass to you, yes or no? Now you tell me, will the postman at your father, how the postman will appear to be, tell me? At your father, how the postman will appear? At your father, how the postman, like a sink. At your father, postman will be like a sink. And at your case, at your place, that means the postman will give the money to you. At your case, how the postman will appear to you? At your place, whatever the money has taken, he will pass you to. At your case, the postman will appear to be a source. But who is the actual source? Yes? Who is the actual source, you tell me? Your father is the actual source. Now you tell me now here. Now exactly same point P. Exactly the same analysis here, the P you can see now. Is it clear? Tell me, all of you. Yes. So that means that is a physical meaning. So that what it is, not just flow. It will, what is the divergence means? What a net flow, tell me, remember. Divergence is what you tell me now here? Net flow from a given point, right? It doesn't, we just want to see the only one side, we can't see, we need to see both sides, then we can conclude whether that is a source or sink or neither source nor sink. That is a thing you have to see. Boliye. Now you tell me, now I have taken this point is something, A I have taken this point is B. Now tell me what I should call A, you tell me what I will call this A here. Here A is called as what you tell me, source. Here A is what we can tell me, source, and point B is called like a sink, and what I can say is point P is a neither source nor sink. P is a neither source nor sink. Is it fine, Boliye? Right. So this is the physical meaning of a divergence. This is the physical meaning of a divergence. So the thing is, remember, our electromagnetic fields, the complete focus is about the Maxwell's equations. Remember, the complete focus is about the Maxwell's equations. So this is electromagnetic means understanding the Maxwell's equations. And to have a clear picture about the Maxwell's equation, you need to have a clear picture about the divergence. You need to understand carefully. You need to understand divergence. You need to understand. And the next we will see the curl. These are the most important topic to understand the Maxwell's equations. Now I will ask one question. Now try to answer my question here, everybody. So देखो इधर all of you. Now all of you देखो इधर. At this point, tell me divergence at this point. Divergence at this point, tell me how much. Divergence here, you tell me. बोलो, सभी बोलना पड़ेगा, सभी रेस्पॉन्ड करना पड़ेगा. Don't sit ideally. सभी रेस्पॉन्ड करना पड़ेगा. What divergence at this point, you tell me. देखो इधर. So at this point, see the field, you tell me now here. This point, field is coming, field is going. Is that point is contributing anything? So will that point is contributing anything? कुछ भी नहीं ना here. That point is not giving, not taking. That point is not giving, not taking. So इसीलिए divergence क्या है? Zero. Is it fine? Now tell me divergence at this point. Tell me here. Here divergence at this point. Zero. Isn't it? Right. Now tell me divergence at this point here. Tell me how much the divergence at this point. Understood the thing? Now tell me actual analysis आपको पता होगा. I think so. Everybody clear this thing here, divergence में. Right. That what? This physical understanding is required. If we can understand the physical meaning, so definitely you fellows will enjoy the electromagnetic fields like anything. So electromagnetic fields, that is just not a mathematical, not a simplification, not the completely problems only. You need to understand the physical interpretation is required, physical meaning, physical understanding is required. तभी you will enjoy करेगा ये topic. So here, so this electromagnetics is my the best forever favorite subject. So this electromagnetics, when I used to teach the electromagnetics, now here I used to enjoy like anything. So here my students should not have any doubt, and so those fellows can able to understand each and every concept. And with the physical meaning, the first my motto of the electromagnetics is, you remember, my thing is I want to make for my every students electromagnetics is the favorite subject. That is my main thing. Yes. electromagnetics. So here I want to make my favorite subject को आपका favorite subject बनाना. That is my primary motto. That is my primary motto. I want to make this electromagnetics as your favorite subject. So for that only I'll try my best. First thing I'll do this thing here. So that is my the primary motto of teaching the subject. Remember. Okay. So here how I used to feel the real electromagnetics. The same thing I want to convey you fellows. I will try my best to make you this as a your favorite subject. And all of you do regularly follow the classes here. You fellows will enjoy the sessions like anything. Fine. Yeah, that's for the today's session. And tomorrow we have the same timings. 9 o'clock we'll meet. We'll meet in the tomorrow session 9 o'clock. Daily we have a 9 o'clock. We'll fix our timings. Daily we'll conduct. Okay then. Okay, see you. Bye bye. Good night. Right. And you can follow me to get the short notes, complete notes and all. You can follow me in the Telegram. You do message me in the Telegram here, B V Reddy. So here you can search the profile there. You can message me. And so I will share the complete short notes and DPP आपको मिलने वाला. Okay. Okay then. See you. Bye bye. Good night.